Hello everyone. I hope you all are doing good. This is Lakshmi Narayana, Senior Physics Faculty. Today we are going to discuss about the chapter of light. Before start the section, give us some time for others to join the class. Okay. If you have any doubts or any queries, please comment in the chat box. Then we will discuss that particular questions or doubts in the chat box. Okay. So yeah. We can see the chat box. So many are joining right now. Okay. Hi sir. Hi. 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 Yeah. So without any delay, can we start our section? Yes. Yeah. So welcome to you all. Today live topic is light chapter. You all are having idea about a light. Okay. In earlier classes, you know what is light and properties, what properties are there. And in today's section also, we're gonna cover all the topics. So let's start the section. Today we are going to start with the topics. What are the topics we are going to discuss here? Introduction of light and what are the properties are there, and see here the topics clearly mentioned: reflection of light, image formation by a spherical mirrors, center of curvature, principal axis, principal focus, and focal length, mirror formula. So these are the topics we're gonna discuss in today live sections. Okay, so light is completely the combination of a topic of reflection and refraction, and today section we're gonna go with the reflection of light. Okay, so without any delay we're gonna start the topic. Clear? Next, introduction of light. Introduction of light. So light is a form of energy, right? Light is a form of energy that produces sensation of vision. For example, if you want to see anything, which is the required light is required. If there is no light, even we cannot see what it is present beside us. Okay, the absence of light we cannot see anything, and without light it's not possible to identify the objects also. So the light helps us to see which is present around us. That's why light is a form of energy that produces the sensation of vision. Okay, for example, without a light, can I move there? It's not possible. Maybe I fell down a number of times without a light also, right? So the light helps us to identify that things and identify the objects which are present around us. We see the objects and we can see that things, and what are the uh, topics are there here. What is that reflection of light? We see the objects when light reflected, when we see the objects and things when light is reflected. Okay, so first light placed on the object, then from the object we get light. Okay, so how it is appear to us? First the light strikes the surface. For example, this is an object. How can I see this? How can I see this one, this remote? How can I see? First, for suppose there is no light, can I see that? No, it's not possible. If there is no light, I cannot see. If the light is present, first light placed on the substance, then after reflection. Okay, so light strikes the surface, light strikes the object or a body, and from the object I will get a light. Then I can able to see which is present. Okay, whether it is a remote or pen or box. Okay, first light strikes the surface, from the surface we get light. Okay, next, the importance behavior of light. What, how the light behavior and what type of behavior it is there. So light is the rectilinear property of light, rectilinear propagation of light. So light is having a rectilinear propagation. For example, if I place a candle here, in lower section we already studied about this experiment. If light takes place and I place a number of cardboards here in front of the light, we arrange the number of cardboards parallelly, you make a hole parallelly, then light passes through the holes, right? Then light passes through the holes. If the person is behind the cardboard, then the person can able to see the light of the candle. So how it is possible? If there is one cardboard is upward, is it possible to see? No. So based on this experiment, what we understand here, the light always travels in a straight line. That is one of the behavior of light. And next, second behavior of the light is reflection property. What is another behavior of light? Reflection property. What is mean by the reflection? Okay, when a light strikes the surfaces, bouncing back of light. If I throw the ball, it bounces. How it bounces back? Similarly, if light strikes any substances, light strikes that any substances, either it bounces back or it passes through. That's why the material, as per the light, we divide it into three types: transparent materials, translucent materials, opaque materials. So transparent allows the light, like lens, glasses. Translucent, it partially allows the light. Opaque means it doesn't allow. Here the reflection, whether the object is present or not, or anything present in front of us, how can we say which is present in front of us? Because of reflection property only. Okay, reflection means is simply bouncing of light. Next, refraction, bending of light. See, both reflection and refraction, when it takes place, means reflection takes place in a single medium. Refraction takes place when a light changes a medium. Okay, when light changes a medium. For example, I am taking a one surface. Here it is a one medium and here it is the second medium. If light travel from one medium to another medium, this is the medium 1 and below is that medium 2. If light changes from one medium to another medium, then it takes place refraction. Regarding the refraction, we will discuss briefly later in another section. Okay. Next, these two ideas explains that mirrors, lens, human eye and optical instruments. So based on this reflection and refraction property, these are the things we're gonna cover in the chapter of light. Okay. Next one, reflection of light. So from the beginning classes, we know that what is reflection of light. So reflection of light is nothing but light returns back to the same medium. So from which medium it traveled and it gets back to the same medium. For example, if I am taking a ball here, okay, this is the wall, this is the wall, okay, this is a wall and this I am taking a ball. If I throw the ball, what happened? Okay, it's some angle. If I throw the ball, what happened? Here it strikes. Okay, here it strikes. So after strikes that, what happened? It come back to the same medium. So which medium, from which medium we throw the ball, it get back to the same medium. That property we called as that reflection of light. Okay, remember carefully, reflection of light is nothing but light returns. Light returns means coming back. Light returns is nothing but coming back to where, from which medium it travel and get back to the same medium only. Okay, it get back to the same medium. This property we call is the reflection of light. So if I throw the ball, it get back into the same medium. That is called reflection of light. Okay, and where it takes place, the reflection of light, it is highly reflection takes place on smooth and polished surfaces like mirror. If I want to see my image, where I can stand, in front of the wall or in front of the mirror, both are takes place reflection. But the thing you have to understand here, it is where I will get my image, in front of the mirror or in front of the wall. Can you guess where I need to stand to get my image properly I need to stand in front of the mirror. Why? Because if I stand in front of the wall, there the reflection is irregular. I cannot get my image clearly. If I stand in front of the mirror, that is a smooth and polished surface, then I will get the image. My image is very smoothly. I will get smooth and polished image. I will get, and I can see that exactly how the image is there. Rough surfaces, it's not possible. Okay. Next. So, what are the examples where we use this? So, the examples of image formation in mirrors, now we discussed. If you want to see your image, you need to stand in front of the mirror, not in front of the other person, not in front of the wall, and not in front of. If I stand in front of the wall, if I am asking to the wall, can you give my image? It gives no. Why? Because it's a property of the wall. It's not polished, it's not smooth. Okay, so the image formation takes place by the mirrors and as well as calm water and as well as shiny metals. Calm water means calm water also gives the image. If you see, that in front of the calm water, you will get the image. If someone is throwing the object, what happened? The water is disturbed. The water is disturbed. So now they see the surface, how the surface will be, how the surface will be, how the surface will be. The surface is irregular. So the irregular surfaces will not form a clear image. Remember, if you want to get a clear image, when you will get a clear image, when you get clear image, the clear image formation due to only polished surface. Polished surface. Because of this polished surface, the reflection takes place is that regular reflection takes place. Which type of reflection? Regular reflection. By the regular reflection only, the image is very, very clear. By the regular reflection only, the image is clear. Okay. By the irregular surfaces, you will not get any type of image. Clear? Next, important terms. What are the terms we gonna use here? Incident ray, reflected ray, normal, angle of incident and angle of reflection also. Incident ray. Which ray we called it is an incident ray? Which ray we called it is that reflected ray? Which ray we called it is that normal ray? See, I am taking one plane mirror here. So the plane mirror has two faces. Okay, if it is a plane mirror, it's two faces, right? One side is smooth and another side is that rough. Okay, so let us think if this side is that rough surface and in front is that smooth surface. So the smooth surface will give regular reflection. Which surface will give image? Regular reflection gives images. And this is that rough surface or coated surface or irregular surfaces. Okay, so the irregular surfaces will not form any type of images. Next, I am drawing a one line here, one ray I am drawing here. Can you tell me that what is that ray? Either it is incident or reflected or normal. How can you say which ray it is that? The thing you have to identify here it is that you have to see the direction. Ray means we represented with an arrow. Ray means we represented with an arrow. So you have to identify the direction, which direction it is there, towards or away. If I am taking towards the smooth surface, towards, the direction is towards the mirror. The direction is towards. So how can we identify it is towards or away? Because of arrow. If there is no arrow, we cannot. Okay, because of arrow. Which direction it is there? Towards the mirror. Then it is incident ray. If it is away, see here it is strikes. This is that where it is strikes, that point we called as the point of incident. Where it is strike, that is called point of incident. For example, if somebody is throwing that object, it strikes here, right? It strikes here. So where it is strikes, that is called point of incident. So here it is strikes, that is the point of incident. After striking the point of incident, see the ray direction away from the mirror. So away from the mirror we call this that reflected ray. Understand that? Two rays, incident ray towards the mirror, reflected ray away from the mirror. And what is the normal? Normal is an imaginary line. Normal is nothing but an imaginary line. How it will be? Perpendicular to the surface. How it will be? How it will be? How it will be? How it will be? Perpendicular to the surface. See, here it is that surface, and see, to the surface it is perpendicular. See, for the incident ray, for the reflected ray it is not. For the surface, where is the surface? This is the surface. To the surface, let us take a perpendicular. This perpendicular line we call it is the normal. The perpendicular line we call it is the normal, and it is an imaginary line. Clear? Okay, incident ray, reflected ray, normal. And coming to that, next point, angle of incident. So what is mean by angle of incident? The incident ray is there, right? This incident ray make an angle with the normal. The incident ray makes, which ray? Incident ray makes an angle with the normal, that is called angle of incident. If reflected ray also makes an angle with the normal, what we call, that is angle of reflection. What are the angles are there? Angle of incident is the angle of reflection. Sir, how can we identify angle of incident? How can we identify angle of reflection? It means if which ray making angle with the normal, that we have to check. If incident ray is making angle with the normal or reflected ray making an angle with the normal, that we have to see. If incident ray makes incident angle, reflected ray makes reflected angle. Clear? Next, laws of reflection. If reflection takes place, we have some laws. What are the laws are there? Here, what are the laws are there? Incident ray, reflected ray, and normal lie in a same plane. Incident ray, reflected ray, normal, all are lies in a same plane. For example, I am taking a book here. Okay, I am taking a book here. Incident ray strikes. Okay, incident ray strikes, and after striking this one, it going back. Reflected ray, and where will be the normal? Here it is the normal, perpendicular to the surface, normal. Where this incident ray, reflected ray, and normal, these three are lie in a same plane. That is the first law of reflection. Clear? Incident ray, reflected ray, and normal, these three are lies in a same plane is called first law of reflection. And coming to that, second law of reflection. What is the second law of reflection? Angle of incident is always equal to angle of reflection. Very, very important. If you want to do the numericals based on the law of reflection, you have to remember this one. Okay, angle of incident is equal to angle of reflection. For example, see, here I am drawing that incident ray, and this is the normal. Okay, normal making angle of 90 degrees with the surface. Here also 90 degrees with the surface. A light ray strikes that. Okay, and this light ray strikes the, makes an angle. For example, let us take this is 60 degrees. Okay, and here also reflected ray also makes 60 degrees. Reflected ray also 60 degrees. So angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection also. If the incident angle is 30, reflection also 30 only. If the incident angle is 45, reflection angle also 45 degrees only. So what is the incident angle? The reflection angle also will be the same only. That is the second law of reflection. Understood? Next, what is an image? What is image? From the comment section, sir, explain once again. Angle of reflection. Okay, see, angle of reflection is nothing but incident ray is there, right? Incident ray towards the mirror, reflected ray away from the mirror. Incident ray, how much angle? For example, reflection angle, I don't know. I don't know the reflection angle. The angle of incident is given 30 degrees. Angle of incident is given 30 degrees. What is the angle of reflection? Say, what is the angle of reflection, guys? Angle of reflection? Yes, 30. Angle of reflection 30. For suppose, if light ray travel along the direction of normal. See, follow here. If light ray travel along the direction of normal, what is the angle of incident? The many students are confusing here. If light ray strikes towards the direction of surface, okay, light ray passing through the normal, what is the angle takes place between normal and incident ray? What is the angle? Anybody? Any from the chat comment box? Anybody? What is the angle takes place between incident ray and normal when the light ray is passing along the direction of normal? What is the angle, ma? What is the angle? Angle of incident is equal to 0. Why angle of incident is 0? If angle of incident 0, angle of reflection also 0. Why angle of incident 0? How the light ray? This is the normal and this is the incident ray. How these two will be? How these two will be? Parallel, right? So if the parallel means what is the angle? 0. So when a light ray passing through the normal and the angle of incident 0. If angle of incident 0, angle of reflection also 0. Clear? Clear na? Yes. Next one. What is an image? Image means when image forms. When an image forms. An image is formed when light rays coming from an object. We already discussed in the beginning. Light ray coming from that. From where it has come light ray? First strikes the object. From the object, light rays coming. Right? So whenever it is coming, these actual light rays meeting or not, that is very important. To form an image, what required? Light rays are intersecting or not? How the intersection takes place? Really intersecting or appear to be meet like that? You have to check these two. Really it is meeting at a point or not, or appear to meet at a point, that you have to check. If really meet, okay, the light rays after reflection meeting at a point or not, that you have to check. If really meet or actually meet at a particular point, there it forms that real image. When you will get a real image, the actual light rays after reflection or refraction, the actual light rays are meet at a point, you will get which type of image? Real image. When the virtual image you will get? For example, if I am stand in front of the mirror, what type of image? If I will go forward one step, in the mirror it shows that one step forward towards me only. Which type of image? There that light rays are actually meeting or appear to be like that, meeting at a point. So there you will get virtual image. Real image means actually meet at a point. There you will get real image. Okay, don't confuse. Real image means actually meet at a point. Virtual image means appear to meet at a point. It is a virtual image. Next, real image. When reflected rays are actually meet, where it takes place? On the screen. Okay, where it takes place? On the screen. For suppose, if you stand at any place, your image is captured on the screen, then that image is real. If you stand in front of the mirror, the image is captured? No. Then what type of image? Virtual. So you see the difference here, right? Which is real, which is virtual. Only the difference is forms on a screen, real. Not forms on the screen, virtual. That's it. No confusion about real and virtual. Forms on the screen or not, you have to check. Forming on a screen, yes, it's a real. It's not forming on a screen, it's a virtual only. Okay. So, and it is usually inverted. The real image is that inverted. Virtual image is that erect. Okay. Virtual image appear to meet at a point. Virtual image cannot obtained on a screen. Remember Remember the point, it's a very important. This point will decide. This point will decide it is a real or virtual. Obtained on a screen. Obtained on a screen, real. Cannot obtained on screen, virtual. Okay, virtual. Virtual image is that erect only. Which type of mirror will give that virtual image? Mostly plane mirrors only. Plane mirrors always forms a virtual image. Plane mirrors always forms the virtual image because it not capture on the screen. Clear? Next, look at the question. Law of reflected holds. Laws of reflection. Laws of reflection hold true for which surfaces? Laws of reflection hold true for which surfaces? What is the law of reflection? Angle of incident is equal to angle of reflection. Incident ray, reflected ray, normal. Okay. Angle of law of reflection. Law of reflection is nothing but take a surface, smooth surface is there, rough surface is there, light ray incident takes a normal. The angle takes place between incident ray and normal, incident angle, and the angle takes place between reflected ray and normal, angle of reflection. Okay, so the law of reflection hold true for which surfaces? Which surfaces? It is for rough surfaces or smooth surfaces, or plane mirrors or concave mirrors or convex mirrors or any other type of mirrors. It holds for all reflecting surfaces. Don't confuse it here. The law of reflection is true for all type of reflecting surfaces, whether it is rough or irregular or whatever it may be. It is applicable for all reflecting surfaces. Clear? It is clear. It is applicable for all reflecting surfaces. Here the question from the chat comment section. Why it is applicable for all surfaces? Very good question, beta. So why it is applicable for all reflecting surfaces? You are also get the same doubt, na? Sir, previously you said regular only forms that plane, regular only forms that image. Other one it's not forms the image. But here the thing is what? Law of reflection. They are asking about law of reflection. Okay, not the image. Whether it is that real image or virtual, they are not asking about those things and all. They are asking about law of reflection is applicable or not. So it is applicable for all reflecting surfaces. How it is applicable for all reflecting surfaces? If you zoom in, okay, where it is strikes that at point, at a point it strikes. At a point it strikes that. If you elongated that particular point, their angle of incident at that particular point, angle of incident is equal to angle of reflection. It holds for all the surfaces. It holds for that all the surfaces. Clear? Clear? If they ask you next time also, the raw reflection holds for all reflecting surfaces. All reflecting surfaces. Clear? Next, list 4 characteristics of the image formed by a plane mirror. Plane mirror characteristics. Okay, what characteristics plane mirror has? Lateral inversion. Lateral inversion property. If you raise the right hand, in the mirror it shows that left hand. If you raise the left hand, in the mirror it shows that right hand only. Yes, clear. So, if you see that the letter of ambulance, how it will be? How it will be letter of ambulance? Why it will be like that? Have any idea? If you see all the letters on the ambulance, how it will be? Why it is like that? Because if you see the thing in the mirror, okay, it will be appear like ambulance. Okay, that is the property of lateral inversion. Raising the right hand, in the mirror it shows the left. Left hand, it shows that right. Clear? Next, it forms that virtual image. Virtual image. Plane mirror cannot capture image on the screen. It always forms the virtual image. We already remember that point. It always forms that virtual only. Next, it forms that erect. It forms that erect. Next, it forms the same size. How the object will be, image also same only. If I stand in front of the mirror, I will get double. No, right? I will get thin. No. So, however the object, the image also will be the same only. So, remember the 4 characteristics. It is having a lateral inversion property and it forms that always virtual only. It is that erect property and it forms the same size. Okay. However the object, image also will be the same only. Okay. Next, mirrors and their types. What is mirror? Mirror is a polished surface. Mirror is what, ma? Mirror is what? It is a polished surface. That's why it is called mirror. If you see your image at any place it is possible to see the image? No, only on the polished surfaces. That's why it is called that mirror. So in the mirror, what are the types we have? Plane mirror. Plane mirrors means how the surface will be flat. Spherical mirror. Spherical mirrors means it is a hollow sphere. You know, plane mirrors means is a flat. Spherical mirrors means hollow. So again in the spherical mirror we have 2 types. How many types in a spherical mirror? 2 types. What are they? Concave mirror and convex mirror. So you are confusing about, sir, which is concave and which is convex. How can we identify the difference between concave and convex? Which is concave? How can we identify, sir? Which is convex? How can we identify, sir? Concave means, see, what is another name of the concave mirror, ma? It's a converging mirror. What is another name of the concave mirror? Converging mirror. Why it is called as the converging mirror? Why it is called? Simply they won't call it is a converging mirror, na? Why it is called it is a converging mirror? For example, I am taking a mirror like this. Okay, inner side is smooth. Inner side is smooth and polished surface. Outside is that rough surface. Rough surface I am marking like this. Okay, so where it will be? Where it will be smooth surface? Smooth surface is inside. Smooth surface is inside. Outside is the rough surface. If light takes place, if I am taking a number of light rays, number of light rays, number of light rays, how it will be? How it will be? After striking the point, it will meet, na? After striking the point, it will meet, na? So what happened here? After reflection, see, this is the light ray. This is the mirror. Light rays are coming. Strikes, coming, strikes. So after reflection, what happened? Look at the directions. Look at the directions. How the directions? Going to meet at a point. It is going to meet at a point, right? It is going to meet at a point. So that means combining at a point. Combining means converging. Converging at a single point. That's why it is called that convergent mirror. Understood? Concave mirror, we call it a convergent mirror also. Why it is? After striking that surface, the reflected rays where it is meet at a point, that is called convergent of light. And divergent means, divergence of light means, here it is that what happening after striking the surface, combining at a point. Divergent means opposite. Divergent means opposite, separated. It will go in different directions after strike the surface. Okay. See here, important terms in the spherical mirror. Pole. What is pole? What is a pole, ma? What is a pole? Pole is the center where on the mirror, pole is a center point. Okay. What is a pole? It is a center on the mirror. On the mirror. Okay. Center of curvature. Okay. What are the center of curvature? If you take a whole mirror, spherical mirror, na, center, it's called center of curvature. Radius of curvature means, radius of curvature, see here, this is the center of curvature, this is the center of curvature. The distance from pole to C, okay, the distance from pole to C is called radius of curvature. The distance from pole to C is called as that radius of curvature. Next, principal axis. What is the next one? Principal axis. The principal axis is nothing but the light ray which passing through the center of curvature and as well as pole. Okay, the light. Okay, light has to pass first center of curvature, then it passes to the pole also. Then that ray we call it is that principal axis. Again we will discuss briefly here. See, pole, central point of the mirror. If you take, this is the mirror, which is the center point. This is the center point, right? Here it is a center point. So this center point we call it is that pole. Next, center of curvature. It means for the whole mirror, for the whole mirror, it is a center point. The center of the sphere of the mirror, which is the part we taken here. Next, radius of curvature, distance between P and C. Distance between P and C. C, pole, center of curvature. The distance between pole to center of curvature, what we call radius of curvature. Clear na? The distance from pole to center of curvature, the distance we call it is that radius of curvature. Okay. Next, principal axis, a straight line passing through P and C. Okay, the straight line passing through that P and C. Remember all the points: pole, center point on the mirror, center of curvature, it is center for whole mirror, radius of curvature, the distance from pole to C. Principal radius of curvature, distance from pole to C. Principal axis, a line passing through C and as well as P. That is called as the principal axis. Okay. Next, principal focus. Principal focus. Remember the term principal focus. After striking that, after the light rays, after striking the surface, where it meet, that point we call is that principal focus. Okay, it is a point. Principal focus is nothing but, F is nothing but what ma? It is a point. It is a point. Where we'll take that point? On the principal axis. Okay, where we'll take that point? On the principal axis. How that point will forms? After striking that, I am taking a concave mirror here. See, number of light rays are striking. This is the principal axis because it's passing through the P and as well as C. It passing through C and as well as P only. And see, number of light ray strikes and it converging at a point. Here it is a one point we taken na. This point we called as focus. This point we called as that focus. Okay, focus is nothing but it's a point. Where we will take that point? On a principal axis only. Okay, where we'll take that point? On the principal axis. Okay, where? On a concave mirror and appear to diverge from a convex mirror. If you take concave mirror, really meet at that point. It's a focus. And if you take convex mirror, it appear to be like that, appear to be meeting at the point because it's diverging. Light rays are diverging here. Okay. Next, nature of focuses. If you take a concave mirror and convex mirror, the difference we have to understand very easily. If you following the section, you can understand that concave mirror and convex mirror differences very easily because concave mirror, how the focus will be real because it really meeting at that point. Convex mirror, it forms that virtual focus. Why it is virtual focus? Because after reflection, how the light rays will be diverging. Remember the point. Concave mirror gives that real focus. Convex mirror gives that virtual focus. Okay. Why it gives real? Because converging of light. Because convergent of light. Why it gives a virtual? Because divergent. Because of divergent, what happened? The light rays are not meet at that particular point. It is appear to meet at that point. That's why it is called that virtual focus. Clear? Next, focal length. What is the next one? Focal length. So focal length is nothing but, we discussed the radius of curvature, center of curvature. What is the focal length, ma? Focal length is nothing but the relation between, the focal length is nothing but, here see, here see, here see, here it is f na, here it is f na, okay, f is what? Focus. So the distance between, the distance between, the distance between pole to focus, here it is a pole, here it is a focus, the distance between pole to focus is called focal length. Okay, what is mean by focal length? Focal length is nothing but the distance, what distance is takes place between pole to focus, that we call it is that focal length. Okay, clear? So focal length is nothing but distance between pole to focus. Here we have to see the relation between radius of curvature and focal length also. F is equal to r by 2, then r is equal to 2f. Here it is the relation between pole and focus. Clear na? Concave mirror always gives the real focus. Convex mirror always gives the virtual focus, because I already explained why it gives real when it gives virtual. Real means really meet at that point because of converging. Virtual means it's not meet at that point. Okay, it is a divergent rays. Clear na? Clear? Next, if you want to draw the ray diagram, we have to follow some rules. Okay, it's not by our own way to draw the ray diagrams. Na? We have to follow some rules and regulations are there to follow, draw the ray diagrams are there. So what are the rules we have to follow just to draw the ray diagrams? Okay, the first one is a ray parallel to the principal axis passing through focus. What is the first point, ma? I am taking a concave mirror. I am taking a concave mirror where it is a pole, where it is a pole exactly center on the mirror, and if light ray passes through the center of curvature and pole, what we call, it's a principal axis. It is a principal axis. Now coming to the point, what is the point? A ray parallel to the principal axis. So what is the principal axis? This is the principal axis. I am taking a one ray. How that ray will be? Parallel. See how the ray will be. How the ray will be. How the ray will be. This is the principal axis, and this is the, okay, this is the principal axis, and this is the light ray. How these two will be? Parallelly, right? So a ray parallel to the principal axis. Okay, after striking the surface, what happened, ma? It passes through the, after strike the surface, where it passes? It passes through the focus. Remember, the first point is that if any light ray is parallel to the principal axis, after strikes the surface, it passes through the focus. If any light ray parallel to the principal axis, it after strike the surface, it passes through focus only. Remember, parallel. If light ray is parallel, how it will be? It passes through the focus. That is the first point. Light ray parallel passes through the focus. Next point, if you take a ray, okay, see, a ray through becomes parallel to the principal axis. A ray through center of curvature retraces its path. It means if any light ray, okay, initially we discussed about, if you take a plane mirror, if any light ray passing through the normal, how it will be? Again the light ray retraces, back, right? Retraces back na. How it will be takes place in a plane mirror. Here also the same thing. What is the second point here? I am going to explain here. The second point is that if any light ray passing through the principal axis. So here the principal axis If light ray passing through the principal axis, what happened? After strike the pole, it reflected back only. After strike the pole, it reflected back. It means how this pole acting here? This pole is acting like a normal. Okay, here also the same thing. After strike the surface, it reflected back. In a plane mirror, here also same thing only. After strike that pole, what happened? Retraces it back. Clear? Next, a ray through center of curvature retraces path. Next, a ray of incident at the pole. A ray of incident at the pole reflects, make equal angles. Reflects, make equal angles. See here. See here how it makes equal angles. I am taking here again a concave mirror, and there is a pole on the mirror. There is a pole on the mirror. If any light ray passes through the center of curvature and as well as pole, what we call, that is the principal axis. And if light ray makes an angle with the principal axis, and here also the same angle, law of reflection is applicable here. Law of reflection, a ray of incident at the pole reflect, makes equal angle. See here, angle of incident is 30. Here angle of reflection also the same only. Here also angle of reflection same only. Next, last one. At least 2 rays are required to locate an image. How many rays are required? At least 2 rays. It's not possible with a single light. Is it possible to clap with one hand? Is it possible? Hello? Is it possible with one hand? It's not possible. How can you clap without one hand? With the 2 hands it's possible. Right? Similarly, if to form an image, how many rays are required? 2 rays are required to form the image. Okay? Remember the points again. First one is what? Parallel. If light ray is parallel, after strike the surface, passing through the focus. Passing through the focus. And if any light ray passing through the principal axis, what happened ma? It retraces it back. Retraces it back. Next, if any light ray makes some angle with the pole, and reflection angle also will be the same only. Incident angle is equal to reflection angle. Next, to form that image, how many light rays are required? At least 2 rays are required. The image is cannot form with that one light ray. I will explain again. See here how it is not possible. I am taking a principal axis. Okay, see, and pole, light ray I am taken, one light ray I am taken, where it strikes, passes like that. So is there any intersection of light ray? There is no intersection of light ray. So it's not forms the image. Okay. So to form an image, how many light rays are required? 2 light rays are required at least. With the single light ray, it's not possible. Clear? Clear? Yes. Next, see the ray diagrams. The ray diagrams are very crucial to solve the numericals. Okay. To solve that any type of problems. The ray diagrams you just understand to solve a numericals. What is the first point? What is the first point? Look at here. Where is the object? Where is the object? Infinity. Where is the object? At infinity. How the light rays are there? How the light rays are there? Parallel. How the light rays are there? Parallel. If light ray parallel, where it strikes? After strike the surface, it will meet at one point. That point what we call focus. From the focus to pole. Of pole to focus, what we call focal length, we call, that is represented by the small letter f, small f. Okay, see how the light ray, where it is the object? Infinity. Where is the object? Infinity. Where is the image takes place? At focus. Where is the image takes place? At focus. And look at here. Second point, look at here. Where is the object? See, object. Object is where? Infinity. And second time, see, first case we take the object at infinity. In second case, where we take an object beyond C. Here it is an object. Here it is an object, the object is beyond C. Here it is at infinity. If it is infinity, how the light rays will be parallel? If the light rays are parallel, where it meet after strike the surface, it meet at focus. Then you will get image at, where you will get the image? At focus only. How the image will be? A point sized, okay, highly diminished. A point size image you will get at focus. And here also, where is that? See, object is going towards the direction of mirror. Object is going towards the direction of mirror. Where it is the object now this time? Beyond C, where the image takes place. Where the C? Here it is image na? Here we take in a object is AB. Listen carefully here. What is the object we take in? AB. And what happened here? AB. What happened? Look at that. Size of the AB. Like this. And look at the image of AB. How it will be. Here what is the image? Here what is the image? Here object is AB only here also. And what is the image? Here it is very point side, highly diminished here. And here object will be at beyond C. Where is the image you will get? Between F and C. And how the image will be, compare both. How the image will be? Here it is. How the object will be? How the image will be, compare it is. Okay. Compare beyond C. Where is the image takes place? The position of the image is between C and F. Between C and F. See here. At infinity. At infinity. Where is the image? At focus. Where is the image? At focus. How that size of the image? Highly diminished. Point size. And what is the nature of the image? Real and inverted. Real and inverted image only. Okay. Infinity. Look at here. If B. I means image. Infinity. F means focus. Object at infinity. Image at focus. Object at infinity. Image at focus. Object at infinity. Image at focus. Okay. Next, what is the size of the image? Highly diminished image, point size. And what is the nature of the image? Real and inverted. Remember the point. If the object at infinity, where is the image you will get? Where is the image you will get? At focus. What is that size of the image? Highly diminished, point size. What is the nature of the image? Real and inverted. Okay. Next, coming to the second point, where is the object? Beyond C. Where is the object? Beyond C. Where is the image it takes place between F and C? The object is C. Object initially at infinity. Then after what happened? The object is towards the mirror. The object is towards the mirror. And what about the image? If object is coming in this direction, image is trying to do opposite direction. Image is trying to do opposite direction. Just compare these two diagrams. Where is the image initially? If the object at infinity, at F the image is there. The object at infinity, if the object at beyond C, where is the image? See, it crosses F na. That means image is going this direction. Object is coming this direction. Clear? Okay. So where is the object? Beyond C. Where the image takes place? Between F and C. And what size of the image? Diminished image only. What is the size of the image? Diminished. And nature? Nature, real and inverted. How the image will be? Inverting image only, inverted image only. Okay. Nature of the image is real and inverted. Next. Now see that. Where is the object? Object tries to do towards the mirror. Remember the point. Object is trying to towards the mirror. Image is that opposite direction. Image is away from the mirror. Object is that towards the mirror. Okay, object is towards the mirror. Image is that away from the mirror. This time, where is the object? At C. Where is the image? Image also at C only. Look at the diagram. Object at C, image also at C only. Now, in this case, what happened? Where is the object? B between C and F. How the object will be C? Here the object is, how the object will be, image also same only. But here, how the object is small. Look at that. Object is small and how the image will be increases na. Compare it to that object, image is increases na. So where it takes place increasing the image? If the object is between C and F, the image is increasing. Okay. Look at here. At C. At C. Where is the position of the image? At C only. What size? Same size. What is the nature? Real and inverted. Look at the diagram. Inverted image. Next point. Where is the object? Between C and F. Where is the object? Between C and F. Where is the image? Beyond C. What type of image? Enlarged. The image is enlarged. And what is the nature of the image? Real and inverted. What nature it has? Real and inverted. Clear? Next. Look at the diagram. Look at the diagram. Can you guess anybody from the chat box? Anyone? Where is the object now? Where is the object now? Where is the object now? Yes, very good. Where is the object? Object AB at F. Object AB at F. Where is the image? Can you guess? Where is the image? Look at the diagram. Look at the diagram. After strike the surface, the reflected rays, it is meeting at any point? No. It is meeting. How they are? Parallelly it is going. If the parallel rays are meet at a point, never. Then where is the image will form? At infinity. Clear? Where the object at focus, where the image get infinity. Next, look at here. Where is the object? Where is the object? Where is the object now? From comment section, where is the object? Where is the object? Between P and F. Very good. Where is the object? Between P and F. See, here it is P, here it is F. Where it will be? Between P and F, the object is there. Where is the image will be? Where is the image will be? See, behind the screen. Behind the screen. Behind the screen. If the object image takes place behind the screen, what type of image? Virtual image. Virtual image. So the concave mirror, when it gives virtual image, when the object takes place between P and F, when the object takes place between P and F, then the image is virtual. Why it is virtual? Because it forms the image behind the screen. If image takes place behind the screen, it's a virtual only. Clear? Look at that. Object at F. Here the image infinity. What is the size of the image? Highly enlarged. Infinity. It's a highly enlarged. And what is the nature? What is the nature? Real and inverted. And the object at P and F. The object at P and F. Where is the image? Where is the image? Behind the mirror. How the image will be? Enlarged. What is the nature of the image will be? Virtual and direct. So look at this. Only when you will get virtual image in a concave mirror, they will ask okay, few questions like this they will ask, where from the concave mirror when you will get virtual image. The answer is, the object takes place between P and F. The object takes place between P and F. The image is virtual. The nature of the image is virtual and direct, and size of the image is enlarged. Clear? So once we recapitulate all, at infinity, object O, object V, image, object. Where is the object? Infinity. Just remember the 3 points. Just remember the first 3 points. That's enough. Infinity. Where is the image? F. Object infinity. Image F. Now see. If object at F, where is the image? Infinity. Same na, both are. If object at infinity, image will be at F. If object at F, image at infinity. Object infinity, image you will get F. Object infinity, image F. If object at F, where the image? Infinity. A, A, A dash, A dash, A, object, infinity, image, F, object at F, image at infinity. Reverse na? Okay. Beyond C, object, where it is the object? Beyond C. What is that? Where is the image takes place? F and C. Object at beyond C, image at F and C. Now see, go like this. Where is the object? Between C and F. Between C and F. Where is the image? Beyond C. That's it. Just focus on the 3 points. Next, where is the object at C? Where is the image? C only. Clear? 3 points only. Infinity, F. F is the object. At position of F, object is there. Where the image? Infinity. If the object at infinity, image you will get at F. Okay, both are quite opposite. Beyond C, between F and C, between F and C, beyond C, the object at C, image also at C only. Okay, infinity, highly diminished, diminished, same size. See, up to here only, diminished, diminished, same size. After same size, enlarged, enlarged, enlarged. Okay, enlarged. And see, if you take only in case of P and F, only in case of P and F, only in case of P and F, where the image will be? Behind the screen, right? Where the image will be? Behind the screen. And what is the size of the image? Enlarged. And what is the nature of the image? Virtual and erect. Remember the point, very, very important. The point is that in which cases concave mirror gives that virtual and erect. Then the answer is that if the object takes place between P and F, the nature of the image is virtual. Clear? Yeah. Take a break for 5 minutes. We will get back into the section after 5 minutes. Okay, I hope you all enjoy the section. Then we will meet after the break of 5 minutes. Then before that, you have to practice whatever the things we discuss in the section. Okay, we'll get back. Hello everyone. I hope you all enjoy the section. I also enjoyed a lot with you. So I think you understand the better all the concepts and all. If you have any doubts, again I'm asking you to please comment on the comment box if you have any doubts or any queries. Okay. So let's start our section with the same energetic way in the same energetic manner. Okay. Yeah. Start the section. Okay. Now see, previously we discussed about a concave mirror and the properties, okay, where the object, where the image will be. Now this time we are going to discussing about the convex mirror and the properties of the convex mirror. Clear? So what is the concave mirror and convex mirror? The differences first we have to see. Concave mirror means the reflecting surface is that bulged inward, okay. The reflecting surface is that bulged outward, it is a convex mirror. So that the difference is that the reflecting surface, how it will be, either it is inside or outside, that we have to check. So see here, I am taking a convex mirror. How I have to identify whether it is a concave mirror or convex mirror? See, this is the surface, reflecting surface. The surface is reflecting surface, how it will be, okay, reflecting surface. And here it is that this is the rough surface. So rough surface we have to mark. Rough surface we have to mark. See, I am taking a mirror, rough surface I am marking like this. Rough surface I am marking like this. Okay, rough surface I am marking like this. And see where the object will be at infinity, where you will get image at focus, how the light rays will be parallel. If light rays are parallel, what is the first point then? Rule number 1. If light rays are parallel to the principal axis, where you will get image, either virtual or real image, if the light rays are parallel to the principal axis, where the image you will get, the image you will get at focus only. No? The image you will get focus only. Na? See, at infinity, where the image you will get at focus. See here how the light rays will be striking at this point, striking at this point. After striking, how the light rays will be, how the light rays will be diverging, how the light rays will be diverging. Okay, see the diverging light rays are meeting at the point, diverging light rays are meeting at the point. See the object, the object at infinity, between infinity and pole. See here, where is the object position, where is the object position, where is the object position here. See how the light rays will be parallel na? Where the object will be at if the object is at infinity, in the image you will capture it at focus on. And look at the second diagram, where it is that object, where it is the object position at here, the object position is here, where the image you capture, what type of image is there, when the object is at infinite, finite distance. See here, where the object at infinity, here it is that finite distance. Look at the differences. Object at infinity, where the image will capture. If the object at finite distance, where the image will capture. We have to check. Only two cases are there in a convex mirror. What are they? The object at infinity, where the image will capture. Okay, that is the first thing we have to check. And the second thing is that at a finite distance, not at infinity, at a finite distance. Okay, so in concave mirror we taken beyond C, at C, okay, or like that, wherever you take that, where the it's a finite distance. So where the image will be captured. Only two cases are there in the convex mirror. Look at the table here. The object position between infinity and pole. Where we'll take object position between infinity and pole. So what is the pole? On the mirror. Pole is a point we will take on the mirror. It's a pole. Okay. So Where is that object between infinity and pole? Where the image will get? Behind the mirror. Where you get the image? Behind the mirror between that P and F. Where you will get? Between P and F. If you take place the object in between infinity to pole, where you will get the object is in between infinity to pole, where you will get image, where you will get image, the image you will get between pole and focus, where you will get the image between pole and focus you will get image. And if the object at infinity, where you will get, you will get it F only na. For concave mirror also the same, for convex mirror also same. So the first property, if light rays are parallel to the principal axis, either it is concave or convex. If light rays are parallel, it started at infinity, where it meet? In concave mirror at focus, there you will get real. Here it is a which mirror? Convex mirror. It is a convex mirror, where it will meet? Here also it will meet at focus, but which rays are there? Virtual. Why it is virtual? Because the light rays are diverging. After striking that, the light rays are diverging. The diverging one, which one? Diverging mirror, which gives? It forms the virtual image only. Okay, remember the 2 points. What are the 2 points? If you take an object at infinity to pole, where is the image you will get? Where is the image you will get? Between pole to focus. If the object at infinity only, the image is at focus. There is no change in that. Object infinity, image focus. In between infinity to pole, where is the image? The image also takes place between pole to focus. And coming to that, nature of the image. What nature it has? Which mirror it is? Convex mirror. What is the another name of the convex mirror? Diverging mirror. Diverging mirror. Diverging mirror means the light rays are appear to meet at a point. If light rays are appear to meet means which image you will get? Virtual image. Okay. So it gives that virtual. And what is the nature of that? Size of the image? Small, erect. Okay. So what nature it is that? Virtual, small and erect. Okay. Virtual, small and erect. And coming to that, if the object at infinity, what is that? Virtual only. And what is the size of the image? Point size and erect image. Remember na? Only 2 points in a convex mirror. The first point is that if you take object at infinity, the image will capture its focus and nature of the image is highly diminished and nature of the images is highly diminished, virtual and erect. And in between infinity to pole, where is the image captures? Between pole to focus. Okay, nature of the image, virtual only. Virtual image, small image and erect. So, if you see the difference between concave and convex, there is no real image in convex mirror. In concave mirror, only one case, it's a virtual image. What is that case? Anybody from the comment section? At what case the concave mirror forms the virtual image? Very good student, very good. Yes. What is that? Where the position? The object is at P and F. Very good. Okay, you're following the section is very effectively, right? So, where is that object? Between P and F. Where is the image? Behind the screen, in concave mirror. What is the nature of the image? Virtual, highly enlarged. Only in that case. The remaining all the cases, concave mirror is that forms the real image only. Clear? Next one. Next. Sign convention. The important one is that sign convention. Important one is that sign convention. Here I will there to help you to get sign conventions and all. Okay. See how to take the sign convention here. The simple way is that how we draw the graph. How we draw the graph. Here we take graph na. Graph positive y-axis, negative y-axis, positive x-axis, negative x-axis, and here it is that origin. Here it is origin. At origin 0, 0. At origin 0, 0. So along the positive x-axis all the values are positive. Along the negative y-axis, all the values are negative. Along the y-axis, positive y-axis, all the values are positive. Here, along the negative x-axis, all the values are negative. Clear? So, see here, see, coming to the height, remember, we will do the sign convention in two cases. Coming to the heights, so heights means you have to see, this is the what? This is the baseline of x-axis. So you have to check whether it is above the x-axis or below the x-axis, because height means we have to check above or below. Okay, don't take it is this is negative side and this is negative side. Don't take like that. Coming to the height only, I'm talking about only height. If it is above the principal axis, okay, this is the principal axis na? This is the principal axis na? So see, above the height, above the principal axis or below the principal axis, only take these two cases only. Coming to the height, only take two cases. What are they? Above the principal axis or below the principal axis? Above the principal axis, above the principal axis, always positive. Above the principal axis, always positive. Below the principal axis, negative. These two are enough for height. For height, above principal axis, you have to check how the object will be, above or below. Above it is there. Tell me from the comment section. The above the principal axis plus, below the principal axis minus, enough. Coming to the height, above the principal axis, below the principal axis only you have to check. Above the principal axis positive, below the principal axis negative. Next, coming to that, direction of incident light ray. See, always we take object left side only na? Object we always take left side of the mirror. Okay, object, see, this is a mirror. Where is the object? Always left side. So incident ray, light rays are coming from this direction, right? Light rays are coming this direction, towards the mirror is coming. Okay, so incident ray direction, the direction of incident light ray, if you take, see, distance towards the right side, positive. Distance towards the right side, positive. For suppose I am taking from pole to at any point here. I measure from pole to point Z. From pole to Z I am taking. Which direction I am taking? Along the direction of incident ray. Then the value of PZ is positive. Why is the PZ is positive? Because I am taking, as per the sign convention, I am taking along the direction of incident ray, positive. Opposite to the direction of incident ray, negative. That's it. Okay. Left side, negative. Right side, positive. Above, positive. Below, negative. Clear? Object will be left side. Clear? Once again you have to see. See. Look at that. Look at the sign conventions. How we take positive, when we take positive, in what cases height will be positive, in what cases height will be negative. What are the direction of incident ray? Along the direction of incident ray, what? And opposite to the incident of direction is what? Once see again. See. Incident ray direction. Direction of incident ray, positive. Or if you take a graph like this, positive x-axis, positive only along the direction of incident ray, negative x-axis, negative only opposite to the incident of direction ray, above the principal axis, positive only coming to the height, below the principal axis, negative. Okay, object is always left side of the mirror. Clear? Only 5 points. Object always left side, height coming to the height, above positive, below negative, incident ray direction positive, incident ray direction negative. So that means 2 positive, 2 negatives. Which are positive? Above principal axis positive, direction of incident ray positive, opposite to the direction of incident ray negative, below the principal axis negative. Okay, object will be always left side. Clear? Next, focal length. What is mean by focal length? Look at the side convention, very important for calculating of numericals. Focal length for concave mirror. negative? Can you guess why it is negative? From the comment section, anybody is ready to tell the answer? Concave, why it is negative focal length? Very good, very good. Why focal length? Focal length means what, ma? Between, the distance between P to F, the distance between P to F. Concave, I am taking a concave mirror. There is a pole, its center. Where is the focus? Here I am taking a focus. The distance between pole to focus. Okay. Opposite to the direction of incident ray. The incident ray direction is like this. Incident ray direction is like this. Opposite to the direction of incident ray. Opposite to the incident of direction. This is called focal length. So focal length for concave mirror is minus. Yes. For convex, positive. Why convex is positive? Because if I am taking a convex mirror, where is the reflecting surface? Here it is the reflecting surface, and rough surface is like this. Where is the pole? At any mirror also the pole is at center only. And where is the focus? Here it is a focus, virtual focus. In the beginning we know that where is the focus? Virtual focus is there. So direction of incident ray, positive. Clear? Concave mirror, negative. Convex mirror, positive. Next, coming to the object distance. Object distance always negative in concave mirror or convex mirror. Why? Because object, how we can take? Object distance, how can we take? This is a mirror. This is a mirror. And here it is the object. Here it is the object. Pole to object. Pole to object. That means the distance measuring from pole to object. We are measuring the distance is opposite to the direction of incident ray. That's why it is negative. Clear? Clear? Object distance is negative. And coming to the image distance also, image distance is positive for which one? Can you guess? Anybody from the comment section? Image distance is positive. Image distance means pole to image. For concave mirror, which side? For concave mirror, which side? Image will be there. Left side of the mirror only, na? Left side of the mirror means opposite to the direction of incident ray, right? So opposite to the direction of incident ray, negative. Along the direction of incident ray, positive. Okay. So always positive. Exceptional for in front of the mirror. In front of the mirror. Mirror is this side. Image is this side. In front of the mirror, negative. On the same side of the object. The object which side is there? Image also same side, negative only. Clear? If it is concave also, convex also, negative one. Clear? Next, what are the uses of mirrors? What are the uses of mirror? Mostly where we will use mirror? Plain mirror means we will use in daily life. If you want to see how beautiful you are, how handsome you are, right? What mirror we will use? We will use only plain mirror. Okay, if you take concave mirror, sometimes you will be enlarged. Your face will be like this. Sometimes your face will be like this. Okay. So, what are the uses of concave mirror? Concave mirror we will use for shaving mirrors. If you want to save that, okay, shaving, if you want to shave a beard, what type of mirror? Plain mirror we will use. Concave mirror we will use. Why? Because enlarging the face. Okay. And where we will use headlights of vehicles. Okay. Headlights of vehicles. Headlights of vehicles we will use. Which type of mirror? Which type of mirror? Concave mirrors only we will use in headlights. Okay. In next case where we will use in solar furnaces we will use to focus at center on focus. Okay. To focus the light rays at F. The light rays focusing at F we will use solar furnaces, and astronomical telescope also we will use concave mirror. And coming to the convex mirror, where we will use the convex mirror in rear view mirrors. Okay, the most of the times they will ask which type of mirror we will use in vehicles. Rear view mirror. Can you guess anybody why we will use rear view mirror only in vehicles? Why we will not go for concave mirror? Anybody? If you use concave mirror, the image will be enlarged. Exactly. If you use concave mirror, how the properties will be there? Sometimes enlarged, sometimes diminished also there, right? So if the vehicle is coming towards you, if it is appearing like that enlarged, what about other vehicles under? By seeing that only we will scare, right? So which type of mirror we will use? Convex mirror use in a rear view mirrors and security mirrors and street lights. Okay, understand the uses, na? Concave mirror, what where we'll use shaving mirrors in headlights, solar furnaces, astronomical telescopes and all. And coming to the convex mirrors, where we will use the convex mirror, rear view mirrors in vehicles. Next, in ATMs and shops we will use, and street lights and all. These are the uses of concave and convex mirror. Clear na? Next one, mirror formula. Mirror formula and magnification. Why we use a mirror formula? Is there any importance of the mirror formula? Yes, we have a few importance are there. Coming to the point by point, in a spherical mirror, the distance of the object we will take it is u. The image distance we will take it is u. Okay, object distance is u, image distance is v. Remember that. Object distance u. Object distance means p to object. The distance takes place from p to object. Image distance means the distance takes place from p to image, that is represented by v. Next, what is the focal length? The distance takes place from p to f. Okay, p to object, object distance, p to image, image distance, p to f, focal length distance. Okay, why we all measure from p only? Anybody guess the answer? Why we all measure from p? Anybody from the comment section? No sir, no sir. Yeah, see, if you want to take a graph, from where you measure all the distances. If I am taking a graph here, I am taking a positive x-axis, negative x-axis, positive y, negative y. From where you take all the distances? From the origin. Why? From the origin only we will get all the distances. If you want to get exact one, from all the distances we will measure from the origin only. Similarly, if you want to get that exact value, all the distances measure from pole. So here the pole is act like a origin. Clear? Next, the formula of the mirror. 1 by f is equal to 1 by v plus 1 by u. What is u? Object distance. What is v? Image distance. What is f? Focal length. The distance from pole to f. Okay. Next, magnification. Magnification. What is mean by a magnification? What is meant by magnification? The magnification is nothing but it's a ratio of object distance by it's ratio of image distance by object distance. Okay, magnification is m is equal to minus b by u. Can anybody guess why it is minus? Can anybody guess why it is minus? Why sir? Why we take in magnification? Magnification is nothing but how the image of the object compared to the how the image will be compared to the object. Magnification nothing but how the image will be. If you stand in front of the plane mirror, is there any changes in image? No changes. However, the object image also same. If I stand in front of the plane mirror, how it will be? Same only. If I stand in front of a concave or convex mirror, the difference will be there. So, the magnification is nothing but how the image will be compared to the object. Okay. So, the ratio of image by object we call is that magnification. Then the formula is minus b by u. Okay. The magnification formula minus v by u. Next, magnification is related to the height of the image by height of the object also. Height of the image by height of the object also. We have two formulas in magnification. What are the two formulas? Magnification is equal to height of the image by height of the object. Height of the image by, in terms of height we have one formula. In terms of distances of object and distances of image we have one formula. Minus v by u. Magnification m is equal to height of the image by height of the object, and as well as coming to the distances, magnification is equal to image distance by object distance. Okay. Now coming to that next one, the height of the object is taken to be positive. When we will take object will be positive, below the principal axis or above the principal axis? Above the principal axis. Above the principal axis positive, below the principal axis negative. Remember the points. Above the principal axis positive. Even in sleep also, if anybody asking about how the object height, positive or negative. You have to check whether it is below the principal axis or above the principal axis. Above the principal axis positive, below the principal axis negative. Clear? Okay. So above the principal axis positive, below the principal axis negative. Okay. Remember blindly. Above the principal axis positive, below the principal axis negative. Next, when you will get positive sign in a magnification, when you will get positive sign, when you will get positive sign in a magnification, magnification m is equal to, what is the formula? Minus image distance by object distance na, image distance by object distance na. When you will get positive sign, when you will get negative sign, what are the signs will be? What are the signs will be? Is there any differences in signs? If it is a plus sign will be there, what will happen? If it is minus sign will be there, what will happen? When you will get plus sign, when you will get minus sign, what is the formula of the magnification ma? Height of the image by height of the object. Height of the image by height of the object in terms of heights, and image distance by object distance. Image distance. What is the image distance ma? Between pole to F. Between pole to F, image distance will be there. Between pole to F, between pole to B, image distance will be there. How will the image distance will be? Minus. How the image distance will be? Minus. How the object distance will be? Minus. Minus cancel. You will get V by U. When you will get V by U? When you will get V by U? When the object distance will be minus. In which case ma? In concave mirror, object distance we always take minus na. Image distance also exceptional one case, image distance also minus na. So minus by minus, what you will get? Positive only na. So if you will get positive, then the image is what? Real image. What is the nature of the image? If you will get positive sign in magnification, real. Clear? So if the magnification is real, okay, magnification value plus or minus, we have to check. Plus real image minus virtual image. That's it. We have to check magnification is plus or minus, plus real images minus virtual images. Okay, you have to check magnification plus or minus. Plus, just remember the signs plus or minus, plus real, minus by minus cancel, real image. Virtual means where the image will be, towards the direction of incident ray na, then the image will be positive, object will be negative. That's why virtual. Clear? Next, coming to the question here, if the focal length of the concave mirror is 10 centimeter, what they given? First take the given information. Focal length is how much ma? 10 centimeter. For which mirror? Concave mirror. Focal length, how it will be for concave mirror? Take the sign convention, plus or minus. Anybody from the comment section? Sir, focal length will be plus or minus for comment section. Comment section, minus. Yes. Focal length will be minus. For which mirror? Concave mirror. Why it is minus? Because measuring from pole to F, opposite to the direction of incident ray, negative. Focal length will be negative. Now the image formed will be, where the image will be? We have many cases, right? If object at infinity, image at focus. If object at beyond C, where the image will be? The object at beyond C, where the image will be? Between C and F na. If the object at C, image at C only. Remember the three cases. Next three cases are C. First case infinity, second case focus, second case beyond C, between C and F, third case object at C, image at C only. Now tell me 4, 5, 6. Reverse. Object infinite, object at C, image at C only. Object at C and F, image will be beyond C, Object at F, image will be infinity. Object at between P and F, exceptional this case, P and F, where the image will be? Behind the screen. behind the screen. This many cases are there na in concave mirror. They are asking about where the image will be. They didn't mention. Only they given the focal length of the mirror. They not mention where is the object. So without knowing the object, where we can say the image will be formed at this particular point? No idea na. So we have to follow this all. Object at infinity F. Beyond C, between C and F. Okay, like this. Clear? Next one. Image formed by a concave mirror is virtual. At what case the image is virtual in a concave mirror? In what case? Concave mirror mostly gives real only, exceptional one case. What is that case? Anybody from the comment section? Anybody from the comment section? Yes, sir. Yes, sir. The answer is between P and F. The object at B and between P and F, the image is virtual and the nature is enlarged, erect. Clear? It's not formed on the screen. Next one. Next, a negative sign in magnification value indicates that. What it represent? Negative sign. In magnification, what it represent? Magnification, m is equal to minus v by u. Where you will get minus? For which one? For concave only na? For concave only na? Concave will get minus na? Concave will get minus na? So, a negative sign in the magnification value indicates that the image is. So, image is what we have types: real image and virtual image. Okay, real image, virtual image. Okay, real image. So, real image means u negative, v also negative, m is equal to v by u, positive. M is equal to v by u, positive. Here, virtual, u negative, v positive. Then minus v by u. So, where you will get minus? Where you will get minus? Which type of is this? This is the real. If you get positive, real, and here it is that virtual. So where you will get virtual? The magnification value indicates that negative. Negative means which type of image it is that? In a concave mirror it is virtual. Clear? Clear? Next, if the size of the object is given is 5 centimeter, object size is given h0 5 centimeter, and the magnification value also is given. See, object height is 5 centimeter and magnification by the mirror is 0.5. That means what happened here? What happened? The size is decreases. Magnification is 0.5 and size of the image hi. What is the formula? M is equal to height of the image by height of the object. Substitute the value. Magnification value 0.5. I am writing 1 by 2. 1 by 2 into h0 na. That is equal to hi. Okay. Magnification into h0. Height of the object is equal to height of the image. So 1 by 2 into height of the object, how much? 5. Then height of the image will be 2.5 centimeter. That is equal to height of the image. Clear? Clear? Next, an object is placed at a long distance. Where the object will be? Where the object will be? Long distance. Did they mention any distance? No. Then take infinity. Long distance means infinity only. Before that any is there? No. So the long distance means the object is at infinity in front of a convex mirror. Convex mirror. So convex mirror. Here it is a pole. Focus. Center of curvature. Object. Where is the object? Where is the object? A long distance. Where is the object? Long distance. Long distance means infinite only. Infinite only. The object at infinite distance. Radius of curvature is given. Radius of curvature is given. Radius of curvature nothing but r is equal to how much ma? R is equal to 30 centimeter. R is equal to 30 centimeter. From the radius of curvature we will get r is equal to 2f na. Relation between focal length and radius of curvature, r is equal to 2f. Then f is equal to, if you want to get the value of f, then r by 2. F value is that 15 centimeter only. So now take the sign convention. R is positive or negative, F is positive or negative. R value is how much ma? R is positive or what? Positive only. Why? Because the incident ray direction is this direction. The direction of incident ray we are taking from pole to F, pole to C, along the direction of incident ray only. So R also positive, F also positive. Okay, what we need to find out? State the position of its image. So we need to find out the image. It means we need to find out what is the formula. What is the formula? Mirror formula. 1 by F is equal to 1 by V plus 1 by U. Object. Here is the object. We need to find out V. F value we know 15 plus 15 or minus 15 plus 15 Y plus 15 because along the direction of incident ray. Object distance we know, image distance that only we going to find out. Object distance is what? Minus infinity, minus infinity. Then image distance will be, where is the image ma? Which side? Which side? The object at infinity, image will takes place at focus na. Image will takes place at focus na. Long distance means object at infinity, image will takes place at focus only na. Then 1 by V is equal to 1 by 15 only, plus 15 or minus 15, obviously plus 15 only. Why plus 15? Because pole to F along the direction V value plus 15 centimeter. Clear? Clear? Clear na? Clear na? Yes. Yeah. So now we will summarize this all the topics what we discussed here. Okay. I hope you all understand the topics very clearly in this section. And the next section, refraction of light, will be start very soon. Okay, so what will there discussed in today's live section ma? Introduction of light. So what is light and what are the characteristics it has, what properties it has, rectilinear property, reflection are discussed. Okay, and what is a reflection are there, what type of reflection, regular reflection or irregular reflection, where you will get uh, real image, when you will get real image, when you will get virtual image. Okay, real image means reflected rays are actually meet, the difference between real and virtual meeting or not, that we have to identify. Okay, really meeting means it's a real, it is appear to meet like that means it's a virtual. Okay, so that is the difference between real and virtual. And coming to the spherical mirrors, what are the types are there in spherical? Concave and convex. Concave means bulged inward, reflecting surface is inward. Convex means reflecting surface is outward. Okay, next, center of curvature. It's a whole mirror, it's a center, principal axis, the ray passing through the pole, and as well as center of curvature. Okay, so focal length, the distance takes place between P to F, and mirror formula 1 by F is equal to 1 by V plus 1 by U. Okay, and magnification, so magnification is nothing but what ma? Compared to the object, how the image will be, whether it is increasing or decreasing. Okay, whether it is increasing or decreasing in the magnification, when you will get plus value. Now I explained very clearly when you will get plus value, when you will get negative value. Okay, when you will get plus value, when you will get negative value. We have two formulas in magnification, in terms of heights, in terms of distances of the object and image. I hope you understand and enjoy the section very well. Okay, so we will meet you in the next section. Thank you guys. Thank you all. Thank you.